All right, so again, 9.4 is called parametric equations. Parametric equations are a set of equations, so there'll be two equations. There's actually three variables because they express a quantity, they express a set of quantities as explicit functions of a number of independent variables known as parameters. So we are bringing in an extra variable this time, specifically t, which represents time. So you're going to see your x equals your y equals like you're used to, but then you're going to have a third variable, which is called t. And what parametric equations do is show you what happens with a function over time. So as time is 0, or time is 1, or as time is 2, and so on and so forth. And that's the variable that's going to get brought in, which is t. On the left of the next slide is the parametric graph, and on the right is the rectangular graph. Notice the overall shape looks almost exactly the same. Yep. All right, so on the left is your parametric, on the right is the rectangular. They look overall the same in shape, but notice that on the left-hand side on that parametric one, they have these little arrows. These little arrows tell you which direction your graph is going as your t increases. So that's how you know that direction. It doesn't necessarily always go to the right. It doesn't always go to the left. Whatever happens is caused by what happens as you make t larger, okay? So if you also notice that it looks like there's a systems of equation there, there are two equations that form a parametric function. As I said before, there's a y equals and there's an x equals, and they both have t. So the first thing we're going to do is actually graph these by hand, and you'll do it with a t-chart. You'll take t, you'll plug it into x, you'll take t, you'll plug it into y, you'll match those two coordinates together, and that's what you will plot. The one on the right is an approximation of what it would look like. So we're going to learn how to do those two by doing something called eliminating the parameter. The left one with the arrows is more accurate. So the first thing that we're going to do is the most accurate way to graph these. But the approximation is still another way to figure out what it could look like. Back to here. Okay, so again, notice the one on the left has your x equals your y equals, and they both have t. And then the one on the right is a rectangular. So parametric has an x equals, has a y equals, and has t. Rectangular is what you know. Like that's your normal x and y. That would be a parabola in this case, shifted to the left 3 and up 1. So underneath it, it says the plane curves are continuous functions whose graphs can be traced without lifting a pencil from the paper. Okay, which means it's not like a piecewise, like you're not going to get apart, then it stops and it starts again. This will be one fluid motion. And points are plotted in the order of increasing values of t. The arrows indicate the direction or orientation of the curve. So you'll get something like a t-chart. You'll plug in your values and you'll point your arrows for the bigger one. The definition of a plane curve, and it kind of said this before, but now it's in function notation. So it says if f and g are continuous functions of t on an interval, then the set of ordered pairs f of t, comma, g of t makes up that plane curve. Meaning if I take let's say I have an x equals, and I have a y equals, whatever it is, I'm going to take t, I'm going to plug it in here, I'm going to take t and plug it in here, and then I, from that, make my x, y coordinate, and then those are the points that you'll plot. So I feel like it's easier when you see it. You'll have a t-chart like this. So notice it's a little bit modified. The first column is now t. You'll take those values, you'll plug them into the x equation, you'll get that. You'll take the value, plug it into the y equation, you'll get that. And then you'll make your coordinate point combinations from the x and the y of each t. And then you'll plot them, connect them, and you'll do the little arrows pointing towards the larger t. So it'll look something like this. It says, sketch the curve given by the parametric equations. Given x equals t squared minus 4 and y equals t over 2. And given that negative 2 is less than or equal to t, which is less than or equal to 3. So this second part is telling you what values to plug in for t. So if I start at negative 2 and then I go to negative 1, 0, 1, 2, 3. those are your t values you want to plug in, and then you're going to plug them in for each one. So first I'm going to plug them into x. So x would equal negative 2 squared minus 4, or 4 minus 4, which is 0. X would equal negative 1 squared minus 4, or 1 minus 4, which is negative 3. X would equal 0 squared minus 4, which is negative 4. X would equal 1 squared minus 4, which is negative 3. X would equal 2 squared minus 4, or 4 minus 4, which is 0. And x would equal 3 squared minus 4, 9 minus 4, which is 5. And then we do y. Y equals negative 2 over 2, so negative 1. Y equals negative 1 over 2, so negative 1/2. Y equals 0 over 2, which is 0. Y equals 1 over 2. Y equals 2 over 2. And y equals 3 over 2. So you could leave it as 3 over 2 or 1.5. You're going to have to graph them anyway, so you could just rewrite it as that. Yeah, there's not a lot of these, but yeah. Okay, so then I'm going to make my x, y coordinates based on the x, y I just found. So 0, negative 1, negative 3, negative 1/2, negative 4, 0, negative 3, 1/2, 0, 1, and 5, and 1 and 1/2. And those are the coordinate points you're going to plot. So 0, negative 1, negative 3, negative 1/2, negative 4, 0, negative 3, positive 1/2, 0, 1, and 5, 1.5. 1, 2, 3, 4, 5, 1.5. And then I'm going to connect them. And then I have to add on the orientation arrows. So the arrows point towards the bigger value of t, or the x, y that I got when I plugged in the biggest value. So because we went in order this way, the arrows are going to go away from the first point I plotted and towards the second. There's not like a specific number of arrows you need. I would say 2 or 3 is plenty. And again, make sure there's points at the end of this. So there should be an endpoint at the start and an endpoint at the beginning, because they gave you a restricted domain to plug in. If they didn't give you a specific range, you could just pick some points to plug in. I would plug in, like 4 at least points so you can get your shape. And then you want to point towards the biggest T you plugged in. Questions so far? All right, now we're going to use the graphing calculator, okay? You would not have this on your test, but this is a good way to check your answers, okay? So open up your graphing calculators. And the first thing we're going to do is actually switch our mode. So you want to go to the mode menu, and you want to look, obviously, where it says, the newer ones actually say full words here. It says function, parametric, polar. I think that's all that you can see on that. Yeah. Oh, and then sequence, okay? So you're going to switch. You should have been on function. You're switching it to parametric. So you want to highlight parametric. And then instead of doing these, we're going to actually do the ones that were on the last slide. So x equals, is that t squared minus 4? Yeah. Great. On y equals t over 2. All right, so first of all, I'm going to go to mode. I'm going to change it from function to parametric. Then I'm going to go to y equals, and I'm going to type in what I just did. When you hit the variable button now, it does t, because you're in parametric, so it knows to do it. T squared minus 4, and then t divided by 2. And now when you graph it, it looks like this, okay? So think about why it's not matching exactly to what we typed in the last time. What did we do with our t-values? Like, how did we know what to put in? Good. It told us a restriction on the t-values, right? So if I go to the window from my graph, notice that there's a t-min, a t-max, an x-min, an x-max, a y-min, and a y-max. If I wanted to look exactly like the chart, I change my t-min and max to match what we typed in. So we went from what, -2 to 3? Is that right? Okay. Now it should match exactly what our graph looks like, okay? You have to be smarter than your calculator, though, because it's not going to give you, like, if you watch it graph, you'll know the orientation of it. But if you just look at this graph, you would need to know what direction to have the arrows on. So that's where your t-chart comes in handy, because you'll know, one, you can watch your graph, okay? When it starts to graph it, it points towards the bigger T. But if you just look at your graph, you would need to know that those arrows get added on. So this is an approximation of what your graph looks like. What you hand drew was a better, accurate picture because of the arrows. They don't have to go by equal increments. Like, there's no rule as to what you plug in, except that -1 has to be the first one. So if I did -1, and then I did 0, and then I did 1, and then 3/2 is 1.5, that's plenty, okay? There's not like a rule of how many you need. And then literally take them and plug them in. So x equals 4 times -1 squared minus 4. 4 minus 4 would be 0. X equals 4 times 0 squared minus 4, which would be 0 minus 4, -4. X equals 4 times 1 squared minus 4. 4 minus 4 is 0. And x equals 4 times 3/2 squared minus 4. 4 times 9/4 minus 4, which becomes 9 minus 4, or 5. And then repeat it for y. Y is equal to t. So literally y would be the -1, the 0, the 1, and the 1.5. You don't need to. Yeah. And then 0, -1, -4, 0, 0, 1, and 5, and 1.5. And then graph. 0, -1, -4, 0, 0, 1, 5, 1, 2, 3, 4, 5, and 1.5. And our arrows point towards the larger T. The overall graph is pretty, yeah. But the functions are different, that's all. Yeah. Biggest T value. Yeah. 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 Yeah, but because you're restricting it from smaller T to biggest T. Yep. Questions? So literally just go back to your T-chart scales on this part. Okay, we're going to learn 3 things in parametrics. That's the first one. Just graphing using the T-chart. All right, second thing is a way to figure out what the graph would look like it's a process called eliminating the parameter. What's the parameter? Did you say T? T's right. T is the parameter, not me. T is the parameter, okay? So if for the goal here, it's to eliminate T from your equations. So you're basically using substitution, okay? You're going to solve one of the equations for T and then plug that one back into the other equation in place of the T, thus eliminating T. You'll get one equation, so it will be a rectangular equation like a parabola or a line or something where you have an x and a y, and you'll graph it. When you graph using this method, you're going to lose the orientation of the graph, so you won't know which direction those arrows are pointing. You'll actually have something like a parabola where you'll put just regular arrows at the end, or you'll have a line where you'll just put regular arrows at the end and not along the curve because you don't know which direction it would be, okay? And so the first method is a more accurate picture of what this would be. This is an approximation. It says the domain on the functions may need to be restricted to graph accurately. So if you have something like a square root or where you're going to graph, you might actually need to, you won't have to, but it might say something about a restricted domain, and that would just be to give you a more accurate picture. All right, so example 3 says graph by limiting the parameter. So I'm going to look at these 2 equations. They should look familiar. Okay. I'm going to pick one to solve for t. So the first thing you want to do is isolate one for t. Pick one. Hopefully one's easier than the other. In this case, which one would be easier to isolate the t? The y. Otherwise, I'm going to have to do plus and minus on this sucker, right? Okay. So if I get y equals 1/2 t and I want to isolate t, I do what? Multiply both sides by 2. So I get t equals 2y. Then I'm going to take what t equals and plug it into the other equation in place of that t. And I get x equals 2y squared minus 4. You can just square it, so I can get x equals 4y squared minus 4. Now, what kind of shape is this? It's a parabola. Specifically, what kind? It's horizontal because the y is squared, right? And remember that the y can't have anything in front of it. So we're going to isolate that y squared. Okay. I can add the 4 first if you want. So x plus 4 would equal 4y squared. And then I would divide by 4 or multiply by a 4th. Yeah, but you'd have to take that 4 out either way. So we did substitution to get rid of the t, but now we're getting this into standard form so we could graph it. Now tell me what you know about this parabola. We said it's horizontal, but does it face right or left? To the right. What else do you know about it? What's the vertex? Other way around. -4, 0. Okay. And if I wanted to draw an approximation of it, 1, 2, 3, 4, that's enough. Okay, you just need to know what direction it faces and a vertex. Now remember, this is an approximation, right? Because think about what we actually graphed before, right? This is the same function. We started here and we came around and we went this way and we stopped and started our restriction. So it's an approximation of what that graph looks like. There are no orientation arrows, so we don't know accurately where the t is. I don't know why I did it over there. I could have done it over here. Okay, but oops. It would have been something like that. All right, now you've got some square roots involved here. So this is where it says like something about a domain restriction. Obviously, these would be restricted because there's a t in the bottom and there's a t that's square rooted. So which of these are going to be easier to solve for t? They both stink, to be honest, right? Because the y has 2 t's, right? And then the x is a t under the square root. So I'm just gonna pick x because there's only 1 t, okay? But neither of them are going to be enjoyable, let's be honest. Okay, if I do x, if I want to solve for t, what's the first thing you gotta do? You can bring the square root out of the bottom by multiplying by it. You could square both sides of your equation, so there's a couple different ways to do this, okay? So what did gut tell you to do? Square both sides. Let's try that. So square both sides. And I get x squared equals 1 squared, which is 1, over the square root of t plus 1 squared, which would be t plus 1. Now I still got to get it out of the denominator. So I'm still going to multiply by t plus 1. And I'd get x squared times t plus 1, but I don't want to distribute that because I'm just going to have to take it out again to get the t by itself. Okay, now I want to get t by itself, so what's the next move? Divide by x squared. And the last step? Subtract 1. That whole thing was just to solve for t, though. Now we do what with it? Plug it in. So I'd get y equals 1 over x squared. Oops, that doesn't go that far. 1 over x squared minus 1 over 1 over x squared minus 1 plus 1. And then we're going to simplify the bottom. These cancel. I get 1 over x squared minus 1 over 1 over x squared equals y. Now what? I can multiply by 1 over x squared, which would be, well, I'm dividing by 1 over x squared, which would be the same thing as multiplying by, like if I wanted to bring it to the top, x squared over 1, right? Keep, change, flip it. So I get y equals, I'm going to distribute this to both. So 1 over x squared times x squared over 1 minus 1 times x squared over 1. And these cancel. And I get 1 minus, these cancel, x squared. Now tell me what you know about this graph. It's a parabola. This time I wouldn't even like try to isolate the x squared because hopefully if you remember like your transformations, I think it's easier to graph using these. You don't have to put it into standard form, which is a parabola facing down that has a shift in which direction? Up 1. So I would literally just shift it up 1 and point it down. Okay, so if I wanted to take the one on the right and isolate the t, first of all, I got to get the t out of the bottom, right? So I would multiply by t plus 1 on both sides. And I get y times t plus 1 equals t. Now, if I have 2 of those same variables, I need to get them to the same side and then kind of re-isolate them. So I'm going to distribute this in. And I get y times t plus y equals t. And then both terms that have the t have to go to one side, and the one that does not goes to the other. So I'm going to subtract the t and the y, and I get yt minus t equals negative y. I'm doing this because there's 2 terms with a t on them. Now I want to factor out that t, and I get y minus 1 equals negative y. And then divide both sides by y minus 1. I'm isolating the t. So t equals negative y over y minus 1. And that whole thing can go in like that. I could have separated it into 2 parts. There's a lot of different ways to do this, okay? But now that has to go into here. Yeah. Say again.
Did you multiply t plus 1 twice?
I did t plus 1 on this side to cancel it, and then I multiplied those. I got that.
Oh, you did both sides.
Yeah, because you got to get rid of it. So to get it out of the denominator, you have to multiply both sides.
Why don't you just like subtract the yt so it stays positive? Or is that
After which step? After here.
Yeah.
You can do that. And then it's that. And then you would still take the t out and it'd be 1 minus y. And then you'd still divide. So that would just be a switch of your signs, but it's still the same. Yeah, that works too. Okay, so now that goes in the next one. X equals 1 over the square root of negative y over y minus 1 plus 1. Now, I would square it. Let me get rid of these so you can see it better. Square both sides. And I get x squared equals 1 squared, which is 1, over the square root of negative y minus 1 plus 1 squared. So it becomes negative y over y minus 1 plus 1. So I just eliminated the square root. So I would combine them into 1 in the bottom first, if you're going to do it that way. I would get x squared equals 1 over. This becomes y minus 1 over y minus 1 if I give them a like denominator. So I get negative y plus y minus 1 all over y minus 1. And I get x squared equals, these cancel. And I get 1 over negative 1 over y minus 1.
And you multiply the denominator.
Now, well, because I see it's an x squared, what do you know about this if it's an x squared?
It's a parabola.
It's going to be a parabola. So instead of moving it to the other side and moving it back, I literally just want to get this out of the, oops-a-daisy, highlighter, not eraser. I want to get that out of the denominator. So how do I get that out of the denominator? Keep, change, flip. Good. So I'm going to keep it on the same side. X squared would equal, but then when I bring it to the top, it flips it. Y minus 1 over a negative 1, which becomes what?
It's gonna be a negative on the outside.
Just, yeah, and then change your signs, right? So negative y plus 1.
Oh. Wait, why does it become 1?
Which one? When I bring this guy to the top, it flips it, right? So y minus 1 over negative 1 times 1 means keep it the same. But then the negative 1 in the bottom changes the signs. So now tell me what you know about this parabola. Well, first of all, this negative can't stay here, right? This would be x squared equals negative y minus 1. Now what do you know?
The center is 0.
The vertex is 0, 1,
And it's facing downward.
and it's pointing down. And again, that's really all you need to know. So 0, 1, pointed down.
Is it gonna be a lot of these?
No, that's like the messiest as it gets. Yeah. And we solved it because they said, let's do the other way. So we did the first way. We actually solved the left side for t. It's still yucky. Yeah, I don't know that it saves you much time because of both sides make it complicated, but it can be done. Questions? Okay. The last thing we're going to do in this section is the reverse. So in this section, in this kind of question, what you get given is one rectangular, which means one without a t, so one that's got an x and a y, and then one parametric where you have the t, and your goal is to come up with two that both have a t in it. So you're going to get given, again, you're going to get given two equations, one with the eliminated variable, meaning no t, and the other one with it. You're going to solve the equation that has the t in it for the other variable, and then you're going to take that and plug it into the second equation, and your answer at the end is going to be two equations, one with an x equals and one with a y equals, and they both should have a t somewhere in them, okay? So the goal is to take something that is half rectangle, half parametric, and make it parametric at the end. These instructions to me on WebAssign are so weird. I kept them worded the same way because I feel like people get so confused by this. But this is two questions built into one. So it says, find a set of parametric equations to represent the graph of y equals 1 minus x squared using the parameters a, t equals x, b, t equals 1 minus x. These are two different questions, okay? What they both have, though, is the one that they give you at the beginning. So they're both using that rectangular with something with t. So for A, you're using y equals 1 minus x squared and t equals x. So of those two equations, one of them is going to have a t in it. We see it, right? X equals t is the one that has the t in it. That one is going to be part of my answer. I would solve for whatever the variable is. This time we just had to flip sides. That's one part of your answer. Then I'm going to take what that t equals and plug it into the other equation in place of the other variable. So if x equals t, then in place of the x, I'm plugging t. And I get y equals 1 minus t squared. And that's literally it. I just made my that's a y equals, sorry. I just made my two equations both with the parameter or the t brought in. So same set of instructions for B. Find the set of parametric equations to represent the graph of y equals 1 minus x squared using the parameters. This time, t equals 1 minus x. So now I got to do a little work. I have to isolate the x. If it was a y there, I'd isolate the y, okay? but this time I'm isolating the x. So I can subtract the 1, negative x would equal t minus 1, and then I can multiply by negative 1 or divide. And I get x equals negative t plus 1, or x equals 1 minus t. That's one part of your answer. Now I'm going to take what x equals, and I'm putting what it equals in place of the x in my other rectangular equation. So y equals 1 minus t squared. And then I'm going to simplify that. So I'm going to expand out the 1 minus t. I get 1 minus, if I were to use the shortcut here, it's square the first term, square the last term, and then double the product here. So negative t times 2 is minus 2t. That's what you get from expanding and foiling. And then I would do 1 minus that. So 1 minus 1 plus 2t minus t squared, and simplify. Y equals, these cancel, 2t minus t squared, or negative t squared plus 2t. I don't care what order you write that in. But there you have your now parametric equations. So 2 equations, both have a t. Yeah.
When you started writing that purple, why did you switch the signs into t and t squared?
Because this negative gets gets distributed to everything after. Questions on parametric. So again, 3 different types. The first one, the t-chart. The second one, eliminate the t. And the third one, bring the t back in.